So hello, and welcome to the Into Rust tutorial series. My name is Nicholas Matsakis, I'll be your humble narrator. I'm a member of the Rust core team, and I've been working on Rust since around 2011. So the Into Rust series takes an ownership-first approach. Ownership is really the core idea that makes Rust into Rust. It's also the part of Rust that's most different from other languages, so it can take a little getting used to. Now, this tutorial that I'm going to do right now basically gives a brief overview of Rust syntax. It starts with the traditional hello world example and proceeds from there. Before we get into that though, I'd like to take just a few minutes to give you the elevator pitch for Rust. What is it that makes Rust interesting? So systems programming has long been one of those with great power comes great responsibility trade-offs. Right? C and C++ give you the control you need to get the most out of your computer, but they're very unforgiving. Small mistakes can easily lead to catastrophic consequences. So if you're lucky, you'll get a crash, but otherwise, you might end up with completely unexpected behavior or a security vulnerability. And this is why systems programming has come to have this aura of being a real superhero endeavor. That's where Rust comes in. So when you use Rust, you get access to those same capabilities that you used to get with C and C++, but now the compiler and the language have got your back. So those same kinds of small mistakes that used to lead to segmentation faults will typically lead to compilation errors, so you can fix them up front. Now if you're new to systems programming, that means Rust lets you get things done without having to worry about small mistakes that are going to bite you way down the line. But Rust isn't just a beginner's tool. If you're an experienced systems programmer, then Rust serves as an enabler. Rust is making sure you've got the mundane details right, so you can build cooler, more powerful programs than ever before. Do you want to parallelize that inner loop? No problem. Even better, if you, or maybe that new person you hired who's still coming up to speed, accidentally introduces a data race down the line, no problem. Rust will catch it for you. Now I'm going to get to the main tutorial now, but if you'd like to hear more about this topic, sort of why Rust is awesome, you can check out the Why Rust screencast. Okay, with that out of the way, it's time to get started with the tutorial itself. Now what I'm going to do is I'm going to start with the hello world example, which is basically obligatory, right? And then I'm going to go from this example into a lot of interesting questions about how Rust handles memory management and safety and so forth. Now, here is the first snippet of Rust. This is hello world in Rust. And I don't really want to talk about it here on this slide. What I'd like to do is go over to this other website. The website is called Play, and it's actually where we're going to be doing all our exercises in these tutorials. So if you're on the main Into Rust website, then right below this YouTube video, there's a link called Hello World for this exercise. If not, then you can see the URL there on the lower left of this slide. So what I'd like you to do is click on that link, and it's going to take you over to the Rust Play website. Okay, let me just bump up the font size a little for you. So, this is a website called Play, and it's a nice way to write Rust code without having to install runtime and all that other things, because you can do it just on the web. So here's our hello world, and you can see what we're going to do. If we go and click run, you'll see we see the output of the program, hello world. Okay, great. And now, what I'm going to do is just play with this example a little bit to give you some more feeling for Rust syntax. So first of all, you can see that Rust functions are defined with the fn keyword, and that the main function is basically where your program will start execution. And inside of there we have one statement, which ends in a semicolon, and it calls this println macro. It calls this println macro, and I'll get into the macro bit in a second. And this will basically dump something on the screen. So this exclamation point you see here, this is how we know that it's a macro. In Rust, macros are things that expand into a bunch of code, right? And the bang operator, the exclamation point, kind of signals that this is a macro expansion. And the reason that println is a macro and not just a normal function is that it lets us do some kind of cool things. So for example, you can insert placeholders into your string, and then what will happen is they'll take, for each placeholder, we'll find the corresponding argument, and we'll substitute that value in. Right, so here instead of writing one hello world string, I wrote hello placeholder, and I put world over there, and now when I run, I'm going to get the same output that I had before. Now normally, you wouldn't want to put the placeholder, you really use placeholders because the value is something that's stored in a variable, or something that will change in different executions. So we can do that. Let's make a variable called name, and this is how you declare variables in Rust. You write let and the name of the variable, and now you can optionally put a type here, but you don't have to, and usually the compiler will figure it out for you. Right, so if I run now, I'll still see the same output. Okay, very cool. Now here's what I'd like you to do. Go off on your own and do these exercises. So you see the goals listed above, so go to rusttutorials.com/exercises and click on the first link to Hello World and try to get play up and running for yourself. And then I'll be here when you get back, don't worry. Oh, you're back. All right. So I don't know if you actually left. Maybe you just liked my singing so much. But if you did, good. And if you didn't, that's fine too for this exercise. But I do really recommend that you go ahead and do the other exercises, because I think they really help to even make the ideas more concrete. All right, so let's go on now. I want to go make this example a little more interesting and introduce a helper function. To do that, I use the fn keyword, and then the name of the function, and then I can give a list of parameters with their name, colon, and then the type. So in this case, we have the name, the parameter is called name, it has a colon, and its type will be string, okay? And here in this space is where the return type of the function would go if it had one. So if we returned an integer, for example, we might write arrow i32 to say we return a 32-bit integer. But we're not going to return anything, so we can just leave that off. And then I'm going to move this println into my helper function. Okay? And now I want to change, instead of calling println directly, I'm going to call my helper function. So everything looks good. Let's try and run it. What happens? Oh, I get an error. Mismatched types on this point. So what's happening here, this might seem a little surprising, what's happening is that the capital string type, this type, in Rust, doesn't refer to just any old string. It actually refers to a heap allocated buffer. This is what you want most of the time, right? So basically, Rust is a language that takes memory allocation and resources seriously, right? And your computer has only finite memory. So usually when you're working with strings, you have to allocate some memory in that space so that you can construct the string in that memory, and maybe you want to add to it or take away from it or mutate it and so forth. And so that's what the string type represents, one of these buffers. However, there's one exception to that rule about having to allocate memory, and that's string constants. Those can be pre-allocated in part of your binary so that we never have to allocate and free them. We just have a pointer to them. And so they have a different type to reflect the fact that they don't need to be freed. So what we can do to bridge this gap is we can convert between those two types. So if we call this method toString, for example, that will take a string literal, allocate a buffer in memory, and copy the string literal into it. Right? And now I have a capital string that I can use. So if I run this code, it works fine. And in fact, there's another technique that I use a lot to allocate a string buffer, which is to use format bang. That's the macro format. And that's exactly like println, except instead of writing to the screen, it just generates a string. Right? So if I run this, the code works fine. And this is kind of cool because I can use placeholders in it. Like, I don't know, this is my name, right? And now this argument Matsakis is going to be inserted spliced into the string Nico and returned into a string buffer to yield the total result. Okay, that's cool. So let's go back to world. Okay, now the nice thing about having a helper function is I can call it twice, right? So let me add a second call and let's see what happens here. So what is this error now? Use of moved value name. Well, this has to do with the concept of ownership, which I mentioned in the beginning is really the secret sauce that sets Rust apart from other languages. It's also the topic of, completely coincidentally, our next tutorial, so I encourage you to go and give that a listen. Thanks a lot.